why does no one dare to admit that Oumuamua might be alien technology? Some of its characteristics seem to defy all known laws of physics. Scientists say it's not a comet, not an asteroid, and may not even be naturally formed. So what is it? Why does every explanation seem to be avoiding a more dangerous truth? On this journey, we won't discuss mysticism. We'll only speak of evidence in pursuit of a more accurate answer. But to truly understand the shock that Oumuamua brought, we have to go back to the moment it first appeared. On October 19, 2017, the Pan-STARRS 1 telescope in Hawaii captured its image. At first, scientists thought it was an ordinary comet and named it C/2017 U1. But strangely, it had no coma and no tail. A few days later, it was reclassified as an asteroid with the designation A/2017 U1. But as calculations deepened, they discovered this object was following a hyperbolic trajectory. In other words, it wasn't orbiting the sun, it was accelerating away from the entire solar system. So scientists had to create a brand new classification for it. It was officially named Oumuamua. This was the first time in human history that we had witnessed a visitor from interstellar space. The name comes from the Hawaiian language and means a scout or messenger from a distant place arriving first. On one hand, it's a tribute to the telescope that discovered it. On the other, it hints at its special status as a forerunner. And from the first second it appeared, everything was wrong. Its speed was too fast, its orbit too strange. It didn't look like any of the old acquaintances in our solar system. It was more like an intruder. It briefly skimmed past the sun, even entering inside Mercury's orbit. There, its speed reached a staggering 87.7 kilometers per second, before being catapulted by the sun's gravity, flying back into interstellar space without a second glance. In just a few short weeks, astronomers around the world scrambled to observe its behavior, and as it tumbled through space, people were astonished to find that its brightness changed erratically, like a very long, narrow, or even flat object was spinning. Early estimates suggested it could be up to 400 meters long, with an aspect ratio as high as 10:1, like a cosmic cigar floating through space. But further analysis of its light curve proposed another guess. Perhaps it was more like a cosmic pancake, with a ratio between 6:1 and 6.61. Whatever its shape, it was unlike any comet or asteroid we had ever seen. It wasn't very large, only a few hundred feet wide, with a dark red surface. This was likely the result of long-term bombardment by high-energy particles during its cosmic journey. But what was most difficult to accept was that it showed no traces of the gas or dust that a comet should have. Astronomer Karen Meech once said, "Even as it was passing by the sun, even with our most powerful telescopes, we couldn't see a single speck of dust coming off of it." But the mystery had only just begun. Its trajectory couldn't be fully explained by gravity alone. As it moved away from the sun, it exhibited a faint, non-gravitational acceleration, as if someone had given it a gentle push from behind. Usually, outgassing from a comet causes this phenomenon. But not a single trace of gas was detected on Oumuamua. This plunged the entire scientific community into a paradox. What is a celestial body with no tail and no outgassing, yet is still accelerating? Was it releasing some kind of substance we simply couldn't see? Or was it not a naturally formed object at all? The public quickly began to speculate. Could it be an alien spacecraft disguised as a celestial body? As for the scientists, while most still leaned towards a natural explanation, every hypothesis they proposed sounded less than plausible, and even self-contradictory. We only know one thing. Oumuamua was here. But what it was and why it came, no one can say for sure. To crack the code of Oumuamua's invisible acceleration, two scientists in 2020 proposed a very bold conjecture. Daryl Seligman and Gregory Laughlin suggested that, quote, Oumuamua's body might not be made of rock, metal, ice, or gas at all, but of an extremely rare substance, molecular hydrogen ice. Their hypothesis goes like this. In the distant depths of the universe, there are regions called giant molecular clouds. The temperature there is close to absolute zero, and it's possible for celestial bodies like hydrogen icebergs to form. This hydrogen ice would sublimate when it gets close to the sun, turning directly from a solid to a gas without needing very high temperatures. And this sublimation wouldn't be a violent jet like on a normal comet. It would be a uniform, quiet, and almost invisible release, as if the entire surface of the object were covered in tiny, invisible thrusters. Because pure hydrogen gas is almost undetectable, invisible in infrared light, it wouldn't shine, nor would it leave a coma or a tail. So visually, it would look like an asteroid, but its trajectory would behave more like a disguised comet. This model is indeed very clever. It explains the two biggest questions at once: why it had no coma, and why it was accelerating. And it could even explain Oumuamua's strange shape. The two scientists pointed out that the continuous sublimation of hydrogen ice would cause the object to slowly lose mass, eroding its edges and elongating its overall proportions. This could explain why it was so long and narrow, like a cosmic cigar. They also emphasized that such hydrogen ice bodies could only form in extremely cold and dense interstellar environments, such as the core of a dark molecular cloud where the temperature is close to 3 Kelvin, the closest place to absolute zero. If, quote, Oumuamua truly set sail from there, it wouldn't be surprising if it had drifted through interstellar space for hundreds of millions of years. And on that journey it was gradually eroded by cosmic rays, until it quietly entered our field of view. This picture is indeed captivating. A primordial iceberg, drifting from the cold, deep frontier of the universe. No tail, no sound, yet carrying a journey of hundreds of millions of years. But this hypothesis also quickly sparked intense debate in the scientific community. Later that year, Thiem Huang and Avi Loeb published a rebuttal paper. They argued that while the hydrogen ice theory sounded elegant, it simply didn't hold up. The first problem they pointed out was starlight. Even the faintest starlight in the Milky Way, shining over millions of years, would be enough to slowly warm and evaporate hydrogen ice. They calculated that a hydrogen ice body the size of, quote, Oumuamua would completely evaporate within 10 million years. Yet Oumuamua's flight path suggests its age could be over 100 million years. On this point alone, the hydrogen ice model was already self-contradictory. Even more serious, if, quote, Oumuamua truly came from the core of a dense molecular cloud, it would have had to pass through large amounts of gas and dust on its way out. These impacts would have made it evaporate even faster. It simply wouldn't have survived to this day. But the most fatal rebuttal was yet to come. Huang and Loeb pointed out that hydrogen icebergs of this kind probably can't form in the first place. The primordial grains of hydrogen ice are extremely unstable and would be disturbed by starlight and heat, dissipating long before they could merge into an iceberg. The conclusion was direct and brutal. A pure hydrogen ice body could not have drifted here from a distant star. It would have melted long ago on its journey, like a cosmic snowflake. This debate is science at its most real. It's not about who is right or wrong, but about a process of constantly pushing towards the truth through refutation. And at this point, the question returned to where it started. If it wasn't a hydrogen iceberg, then what was it? In this cycle of hypothesis and refutation, the scientific community welcomed the next new idea. And that is the clue we are about to discuss. After the old hypotheses were overturned one by one, a new explanation finally surfaced in 2023. And this time, it made many scientists nod in agreement. The hypothesis was proposed by chemist Jennifer Bergner and that familiar name, Daryl Seligman. They teamed up again to offer a more realistic possibility. Oumuamua might not be made of some rare hydrogen ice at all, but just a very ordinary icy celestial body. It was more like a fragment of a comet. But during its journey of hundreds of millions of years, it underwent some unexpected transformations. Their vision is this. This water ice-rich body was constantly bombarded by cosmic rays as it traveled through interstellar space. These high-energy particles could penetrate deep into the ice and trigger subtle but real chemical reactions. We know from laboratory experiments that when water ice is irradiated, some of its molecules break apart to form molecular hydrogen gas, which then gets quietly trapped within the ice structure. This hydrogen doesn't escape, but is trapped in the amorphous water ice, hidden in the tiny pores of the ice body in the form of microbubbles. Over millions of years, this celestial body quietly accumulated a considerable reservoir of hydrogen gas. Until 2017, when Oumuamua first entered the solar system and headed towards the sun, it began to warm up, but not in a dramatic way. Its surface temperature never got high enough to melt water ice, and no water vapor was detected in observations. But this little bit of warmth was enough to awaken the dormant energy within it. As the temperature rose, the water ice began to recrystallize. The structure of the ice was rearranged, and the hydrogen gas that had been trapped in the pores was released. This process was gentle and stable, but it was just enough to create a slow, continuous thrust. Bergner and Seligman calculated that if this body released just a few tens to hundreds of grams of hydrogen per second, it would be enough to cause the non-gravitational acceleration we observed. And what's more ingenious is that this release process is silent. Hydrogen is extremely light and stable. It doesn't glow, it doesn't reflect light, it has no tail and no coma. Even if there was dust mixed in the ice, the particles would remain trapped in the ice layer and wouldn't fly out at all. And so you get a form of propulsion that has thrust, but no trace. It sounds almost like a stealth engine. This is an extremely elegant explanation. Ordinary water ice plus cosmic rays form trapped hydrogen. Add a little bit of heat from the sun, and you can activate an almost undetectable propulsion mechanism. It doesn't require exotic matter or complex conditions, and it perfectly matches all the known characteristics of Oumuamua, a dark red surface, consistent with a comet remnant that has undergone long-term space weathering, no detected gas, a small size, and the non-gravitational acceleration in its flight path can all be accounted for. In the end, Bergner and Seligman came to this conclusion. Oumuamua is likely, in essence, just an ordinary comet-like body. It's just that it slumbered for too long on the frozen frontiers of the universe. And in that long wandering, it quietly accumulated a hydrogen-driven engine in its icy depths. And when it was awakened by the sunlight, it began its invisible escape. It had no dazzling tail, no visible reaction, yet its actions performed a true act of camouflage. The reason this disguised comet hypothesis quickly gained traction is because it pieced together all the scattered clues without resorting to alien spacecraft, black technology, or exotic matter. Such a strange phenomenon could finally be explained by such a simple, elegant, and believable explanation. And this explanation also leaves us with a warning. Sometimes, the things that seem most mysterious may just be us misreading their silence. And the story of Oumuamua might be just that. It didn't come to disturb us, but to remind us not to just look at the surface, and not to jump to conclusions. While we were still debating what Oumuamua was, another deeper question was never really answered. Where did it come from? We still only have some vague clues about its origin, but scientists have already proposed several plausible speculations. As early as 2018, astronomers tried to trace its orbit backward. The results showed that it may have been wandering in the Milky Way for hundreds of millions of years, until, by some chance, it happened to pass close to our Sun. Its direction of flight was from the constellation Lyra, near the region of the star Vega. But the problem is, by the time it actually passed through that area, Vega was no longer in that position. It had been flying for so long that even the positions of the stars had changed. So how did it leave its own star system? The mainstream view is that it was likely kicked out during the formation of planets in a young star system due to gravitational chaos. In the early stages of a planetary system, newborn bodies often collide and compete for position. And those giant gas planets, like gravitational slingshots, can fling small bodies out of the entire system at very high speeds into interstellar space. In fact, our own solar system is the same. Gas giants like Jupiter and Saturn have likely flung trillions of comet-like bodies into the distance, forming what we now know as the distant Oort cloud. So Oumuamua's home may have experienced a similar scene. One or more rogue giant planets like cosmic cannons flung it into its long cosmic journey. Another possibility is that it came from a binary star system. Some research suggests that these dual star systems are particularly unstable in their early formation and are especially prone to ejecting celestial bodies. And another, bolder guess is that Oumuamua might not have been flung out, but knocked out. It might have originally been part of an exoplanet similar to Pluto, mainly composed of nitrogen ice. And it was shattered by a violent impact, and, quote, Oumuamua is one of the fragments that flew out. Interestingly, this theory also tried to explain Oumuamua's acceleration with nitrogen sublimation, but this hypothesis has more problems than the hydrogen model. The mainstream scientific community currently believes its credibility is far lower than the water ice releasing hydrogen mechanism mentioned earlier. Today, it is already more than 40 astronomical units away from the Sun, 40 times the distance between the Earth and the Sun, far beyond Pluto, and is still accelerating away. We are now trying to shift from being passive to being active, from waiting for miracles to creating opportunities. The next time a messenger from a distant star system flies through our solar system, we may no longer just have to look up, miss it, and regret it, but we can reach out and get closer to it. The question is no longer whether we will meet Oumuamua again, but when we will meet the next one. And every interstellar visitor could bring an awakening that transcends Earth, a journey that breaks boundaries, a deep dialogue about the nature of the universe. We don't know where they come from, and we don't know where they will take us. But one thing we can finally be sure of: the next time that strange star once again breaks into our sky, we will be ready to welcome it.